In this video, we're going to take a look at OOP, Object-Oriented Programming, which is a feature of C# and also Unity as a whole. So let's dive right in, open up Unity. And within the project window, let's go to Assets, Unity with Cocktails, Lessons, Lesson 2.2 OOP. So I've already got that scene opened up. Let's go ahead and give it a run. We see in the console window we've got quite a bit of information tracing out. So we'll take a look at that step by step. To jump into the code, let's just double click on the C# file there. This is the sole C# file that gets kicked off because it's attached to the manager's game object. There's a few other C# classes that are used along the way, which we'll see too. So inside this lesson 2.2 OOP, we've got lots of comments per usual. Here we've got the start, which is called exactly once when we play the game. We've got lots of traces here. So let's take a look at what we've got. So jump back into Unity. Let's look at what we have in the instructions 3D text. So to take a look at the output, I simply pressed play, then I looked at the console on the right, and then I pressed stop. Some of the principles of OOP, in a general sense, OOP is a feature of many programming languages. It's a way in which we organize our code into classes, and these classes serve as black boxes, is the expression often used. A black box meaning we don't know what's going on inside the class necessarily. We use the class from the outside, and we take advantage of simply calling a method, not necessarily caring what the implementation details are. Those don't need to be part of what we're concerned with unless we're authoring that method. So it's a way to break your project up into classes, have the classes take care of themselves, and then expose methods and properties to the outside. So the four core principles are abstraction, encapsulation, inheritance, and polymorphism. You may be familiar with all three of the first ones, but polymorphism simply means you create very similar instances from two different classes, and you're able to call and treat them in a very similar way, yet they actually do quite different things, and there's benefits to setting your project up for that way. For instance, you may have a class that is the enemy, and then you may subclass each of those using inheritance and call the first one walking enemy and the second one flying enemy. And as you are programming your hero or core player, each time your player shoots either of those enemies, it might call the enemy.takeDamage method, which is something common to both of those. But perhaps the flying enemy, its implementation when it takes damage is to fall to the ground. And the walking enemy, when it take damage is called, it does something different. Perhaps it falls to the ground in a different manner, or perhaps it starts to run, escaping your attacks or something like that. So both of them have take damage as a public method, and the implementation and what actually happens is different. So that's polymorphism, and a moment on inheritance. This isn't meant to be an overview of OOP in a general sense. It's more just the specifics within how we do OOP within Unity and within C#. So jumping into the project, let's see a couple of these. So inside of our lesson, inside the start, we have a beer class, and I instantiate a custom beer, right? So Budweiser beer. Then I show being able to call public static methods. I show public methods. Here's a little bit of reflection. I'm able to get the type of that instance, which should show that it's of a type beer. You may need to check the type of objects at runtime. Reflection is a general term for what we can tell about a given data type. So getting its type is one part of that. Then we're able to see if Budweiser beer is of type beer. That would return true or false, in this case true. And if Budweiser beer is of type beverage, and we'll take a look at the beer class and the beverage class in a moment. Then separately here, I have a soda class, which I make an instance of Coca-Cola. And what I'm illustrating here is that the polymorphism concept I mentioned before with take damage is illustrated here. Both Budweiser, which is a beer, has a name property, and Coca-Cola has a name property as well, and it's of type soda. So you can see we're treating them in a similar way, but perhaps the implementation details would be quite different. Name could have a different value. Name could actually be generated in a very different way. In this simple project, they are pretty similar. The first one's going to return Budweiser. The second one's going to return Coca-Cola. So let's look at the output just to compare what we've just talked about. And it would be good for you to run this and look through it yourself. But each of the lines in the project where we've called debug.log have a corresponding line here. So the name of Budweiser, the Budweiser beer class instance is Budweiser. Then we're tracing out, is it healthy? Here's the sample private method, the sample public method. Different values down there you can take a look at. And then the very end example, we see beer.name is Budweiser in the instance of the Budweiser beer class instance, and then in the soda instance it's tracing out Coca-Cola. Okay, so you can take a look at the specifics of the console and compare that to the code outside of the video. But what I want to look at is the classes themselves. So if we look at here in MonoDevelop the other scripts that are in use, we have first a beverage class. Beverage class does not extend anything. It doesn't take advantage of inheritance. It is a type that has no parent, let's say. So any functionality we want in beverage, we need to code ourselves. If you inherit from an existing class, a custom class, or a built-in class, you get to take advantage of functionality that's already there. But here we're creating our own custom class, and we're not extending anything. So in beverage, we've got a public property, which is the string of the name. And then we've got the constructor. Constructors are called when the new operator is fired, which I'll talk about in a moment. And inside the constructor, we're taking in the name that we want to call this particular instance. 968, we set the incoming name value to the permanent name property. And then I trace out a few things there using debug.log. So what we can see here in this code is that virtual is different from abstract and is different from simply if we call it public. Okay? What we're indicating here with virtual is that you can override this method, thus changing what happens in the implementation for the subclass, but you're not required to do that. Abstract, on the other hand, you would declare an abstract method in a superclass here, such as beverage, and then in the beer class or the soda class, you are required to override and to give it functionality. So you have a few options there. In this case, you can imagine that a beverage class may have a take a sip method or take a drink method, which is a way to reduce the volume of liquid inside of it. And perhaps if you were subclass that into a can or subclass that into a bottle, you might need that taking a drink to operate differently. Okay, depending on the course of your game and how the graphics are laid out, that may be a different animation you're playing, etc. So the concept of declaring a method in a superclass and then optionally overriding in a subclass gives you flexibility. You can have the superclass handle the functionality, or you can have a subclass optionally override that. So let's take a look now at the beer class from our demo. And the beer class, you see it's declared in a similar way, but after this colon, we're specifying what class does it extend from, what does it inherit from. So here, the beer class is going to extend beverage and take advantage of everything that the beverage class has, which again is that name property that's exposed in that sample public method. Then we're going to be adding new things. So we're adding what is called a getter setter. You may be familiar with that from other programming languages. From outside of the class, we're able to access calories as a public property. But you can see under the hood, each time someone gets that value or sets that value, we're able to control what happens. Here it's not doing any sort of validation or anything, but you could. Inside the set method in line 56, you could check to make sure that the value it's being set to is between 0 and 1,000 or whatever the range is that you think is appropriate. But here I'm just demonstrating you could optionally control the access in and out. Then I'm declaring a variety of other properties. Here we see the method, and this is something that's unique to C# from my experience. When you declare the constructor of a subclass, you can pass in name string and container type string to beer and immediately pass on that name string to the superclass. So you could take advantage of doing some of the work here in the beer class and some in the superclass. I'm actually right here doing work with the name string anyhow, but just so you know the syntax there, if you want a constructor to have different number of arguments coming in the subclass, you can do that. And then I just call some of the simple methods here. I think that this project is most useful for you to just dig in, check it out, copy and paste it into a project you're working on. You can see syntax that works for declaring superclasses, subclasses, the methods, overriding methods, etc. But I'll just go through a couple of highlights. So that sample public method, which we saw here in the beverage class, is here. It's a virtual method, which means we can optionally override it if we want. Now what happens when we call override here is that our beer class is saying, okay, I know my superclass has sample public method declared, but ignore that. I don't want you to use that necessarily. I want to be able to do my own things. From outside the class, we don't know the details of that. We're going to create a beer instance and we're going to call sample public method on it. We don't know necessarily from outside as we're using it if beer has the method or if beverage has the method, just like in other programming languages. So the override keyword here helps us override. Then in an override method, you may just want to return some custom value, right, in that way. But what I'm showing here is that you can do a mixture of I want to override, then I want to call the base method again. So the long story here is that I'm not truly taking advantage of overriding. I'm overriding and then simply calling the superclasses method, which seems a bit ridiculous to do that, but this is a simple example. You may want to tweak that value. You may want to do the superclass beverages functionality and then tack on some other things. Perhaps you would do something like this and then tweak that value before you return it. Then we've got public statics declared. I think that's it for that class. And then let's take a look at soda. So soda also extends beverage. So when I look here, we see soda colon beverage, just like before we saw beer colon beverage. So you could think of beer and soda being on the same level in the hierarchy, and they both borrow from a parent, which is the beverage class. So here we're doing nothing in particular. Okay, soda's really not doing anything. It's pretty much acting like a beverage class. If I could override that method, just like beer does here, I could tweak the values of what's happening inside here. You can see what's happening here in the order of execution. Let's see the lessons project. When I execute new soda, that jumps into the soda class and calls its constructor. Constructor looks just like a method, but the method name must match the class, so it's soda with a capital S. And all we're doing here is taking that name in, passing immediately to the base constructor, which is beverage. And inside the beverage class, here comes that name, and it's being declared here. Okay, so beer represents a more tweaked, more changed version of beverage, and soda represents a almost unchanged subclass of beverage. Soda really behaves just like beverage, at least in this example. The other thing I want to show here, let's look at these two log statements. I'm doing an is operation check to see if the instance of Budweiser beer is of type beer. We'd assume yes it is because it's been declared using new beer in line 87. But if we checked if Budweiser beer is of type beverage, should that return true or false? Because its class type, beer, has a superclass beverage. But let's see in the output where we're at here. So the type of beer, yeah, here we go, these two lines. Budweiser is beer, that is true. Budweiser is beverage, that is true as well. So you may need to do some sort of reflection check in your code to check the type of beer or the type of soda as an instance, and you'll be able to see, oh yes, they're both of type beverage, so we can treat them in a certain way. Okay? And let me think if there's anything else I want to take a look at here in the source code. No, I think that's it for the example. Let me just jump back into Unity and see if we've talked about each of these. So let's see, polymorphism, they both soda and beer have a name property, and we can interact with the name property from the outside, just like this. So we feel like we're treating them the same way, but the implementation details may be different. So that is an example of polymorphism. Inheritance, both the Budweiser beer class, the beer class and the soda class inherit from or are children of and borrow the functionality of the beverage class. That's an example of inheritance. So any public properties in the superclass are available as you're using the subclass instance. Then encapsulation, an example of that. Encapsulation is, again, that black box example where we're able to hide the details of something. So inside beer, I remember there's an example here. So one example of the many in here of encapsulation is that we are able to access calories from the outside. I'll do a quick example of that. Let's say here, and I want to say with calories Budweiser beer dot calories. So I'm accessing calories there and tracing that out. And let me just go ahead and run that. With calories of 0 in that line. Okay. So what that's doing when I call is that inside the beer class, it's getter, since I'm checking the value, I'm not setting it, I'm just debug.log the calories value, it's going to return it here. And where is that value set? Well, it is, maybe it's never set. Let me look again. Calories, okay, and calories, okay. Doesn't have a value, so it's defaulting to 0. So let's take a look at what we could do. We could just set it here to 310, or more likely a beer, I don't know, 200 calories. So let me run that again. And you can see here the highlighted line shows 200. Now, what encapsulation means is that we have details of implementation. How is the value of calories determined and what are the particulars? We have those details hidden. Because outside, when I'm inside lesson class and I'm using the beer and I'm using the beverage instances, I don't care about the details of calories. So it's a very basic concept. It may seem almost an obvious way that the programming should be set up, is that from outside we're using something of calories, in this case, and the inside we don't care how it's actually implemented. Same with methods. We can call a method name and it could do 10, 20, 30 things, no things. It doesn't matter to us on the outside as long as it's accomplishing what we expected from the outside. And abstraction. Abstraction is the process when you're creating a data type and you are putting in the essential pieces and abstracting from, in this case, a reality. We know what a beer is, and it's a type of beverage that has calories, it has a name to it, it has a container type of either, let's say, a bottle or a can. So when I'm creating the data type, I abstract or I generalize that information into the class. You could also think more about a beer and think that it is, perhaps it has a country of origin where it was created, and that could be an additional property that we would expose from the inside, and then we'd be able to set which country it comes from, in this manner. And that, again, in the process of abstraction is just thinking about a real-world data type, a real-world item, and then we calculate what parts of that real-world experience we want to articulate with the public properties in there. So that's it. That is OOP inside of Unity. And in future videos, we're going to take a look at exactly why OOP is so important. It's a good programming paradigm to use in a lot of types of projects, but in games it's particularly relevant. And in Unity, the way that the components interact with the game objects, which is a fundamental of how we're going to program. We'll cover that in a future video, and we'll see that that is very much object-oriented, in that each of the components are separate entities that can access each other using the encapsulated properties and methods of each one. And that's it. Thank you.